A member in a subclass can redefine a member in its superclass. This is most often done to give instance methods new implementations. To demonstrate, we'll override rectangle's getArea method by redeclaring it in triangle with the same method signature. The signature includes the name, parameters, and return type of the method. The access level, however, can be changed to allow for more access, but not less access than the redefined method. In order to show that this override was intentional, Java wants us to add the override annotation. This annotation was added in Java 1.5 to prevent accidental overrides, although it's not mandatory to use it. Now, if we create a triangle and call the getArea method, triangle's version of the method will get called. If we upcast the triangle to a rectangle, triangle's version will still get called, because rectangle's version has been overridden. Note that this is only true for instance methods and not for class methods. If we add a class method called newArea to rectangle and redefine it in triangle, then triangle's version will only hide rectangle's implementation, and therefore we won't need to use the override annotation. Calling newArea from triangle's interface will, as expected, invoke triangle's version, but calling the method from rectangle's interface will now invoke rectangle's implementation. Redefined instance methods will always be overridden in Java, and redefined class methods will always be hidden, and there is no way to change that, as can be done in, for example, C++ or C#. If we want to prevent an instance method from being overridden in subclasses, we can declare it using the final method modifier. Note that the order of these modifiers is not optional, and if we mix up the order, the compiler will point that out. An overridden method can still be accessed from inside the subclass's instance methods using the super keyword, which is a reference to the current instance of the superclass. Another place where the super keyword can be used is on the first line of a constructor. The super keyword is then used as a function call that invokes the superclass's constructor. If the first line of a constructor is not a call to another constructor, the Java compiler will automatically add a call to the superclass's no-parameter constructor in order to make sure that all ancestor classes of this class are properly constructed. Note that because we added a constructor to rectangle, Java does not create a default constructor for the class, which gives us an error. To fix this, we need to manually add a no-parameter constructor to rectangle.